Hello everyone, I'm Shivani and welcome to Civil series. So this is the next video after the completion of strength of material short notes. So this video gives you a quick overview of short notes of strength of material. So here we do a 20 MCQs thoroughly, and we'll start with the first MCQ. Okay, first MCQ. So first MCQ is identify the correct expression among the following. Okay, so what is the correct equation? Here, by observing the options, here Young's modulus is given, here Poisson's ratio given, Young's modulus and Poisson's ratio. Okay, here we write first the formulas of Young's modulus and Poisson's ratio. So Young's modulus is also known as modulus of elasticity. Okay, Young's modulus is also known as modulus of elasticity. There are three types of modulus of or elastic constant. In that, first is the Young's modulus, which is known as modulus of elasticity. Young's modulus represented by E. Second one is bulk modulus. Bulk modulus is represented by K. And third one is modulus of rigidity or shear modulus. Okay, these are the three elastic constant. And here the shear modulus is represented by E, also known as modulus of elasticity. And formula is stress by strain. Formula is stress by strain. And unit is Newton per mm square. Okay, this is the unit for Young's modulus. Then next formula is about the Poisson's ratio. So Poisson's ratio is nothing but ratio of lateral strain to longitudinal strain. Lateral strain to longitudinal strain. Okay, by observing both of the formulas here, we'll decide which option is correct here. Okay, here they ask a correct option. So first is Young's modulus is equal to strain by stress. So here stress by strain is correct. So first option is not correct. Then second, lateral strain is equal to Poisson's ratio into longitudinal strain. Okay, here we take this denominator term into this side, and if we multiply this longitudinal strain with Poisson's ratio, then that answer is equals to lateral strain. So option number second is correct here. Okay, but we'll see the next options C and D. So C is Young's modulus is equals to strain into stress. So here multiplication is incorrect. So option C is wrong. Then next is lateral strain is equal to Poisson's ratio divided by longitudinal strain. So here divided is also wrong. If here they give a multiply sign, then it's correct. So option D is also incorrect. So option B is the correct answer. The next question. Then question number second. A steel bar of 8 mm is heated from 10 degrees Celsius to 25 degrees Celsius and the bar is free to expand. The bar will induce. Bar is free to expand, then it will induce. What it will induce? So first, if a temperature increase on any material, it increases its size or length. Here we take a length. If temperature decreases, it decreases its length. Okay. And if the expansion and contraction is prevented, or restricted. Okay. Then internal resisting force is generated. If expansion and contraction is prevented, then internal resisting force is generated, and that is known as a temperature stresses or thermal stresses. Okay, thermal stresses and temperature stresses. Okay, so what is the change in length? So change in length here we represent with the help of dl, which is delta into L into alpha. Okay, so and if the thermal strain is nothing but a change in length to original length. So here delta into L into alpha is equals to L divided by L. L cancel here. So delta into alpha is nothing but a epsilon t. Okay, but in this question they mention free to expand. Free to expand means here no restriction or no prevention is there. No restriction means no stress. So answer is B. If they here mention they prevent to expand or they stop to expand, then tensile stresses or thermal stresses induce, then temperature stresses and thermal stresses induce, not a tensile stresses. Okay, prevented, then thermal stresses. If free, then no stresses. So option B is correct. Then question number third. So third question is, when a round bar material with diameter of 37.5 mm. So here we write given diameter is 37.5 mm. Then next length is 2.4 meter. Then Young's modulus is 110 giga Newton per meter square. Then shear modulus represented by G 42 giga Newton per meter square. Then stretched for 2.5 mm means delta L, change in length. Okay, which is 2.5 mm. Then they here mention bulk modulus will be. So bulk modulus means K. We need to find out the K here. Okay, first we convert the meter into mm for easy calculation. So 2.4 mm, if we convert meter into mm, then this is the conversion. 1 meter is equals to 1000 mm. So here 2400 mm. Okay, then 110 giga. So 110 giga means 10 raised to 9. And for converting this meter into mm, here we take 10 raised to 3 for 1 mm, but here they give a square. So here we take 6. Okay, so after cutting the values, here we get 10 raised to 6 and 10 raised to 9 cut. Then here 10 raised to 3 is remaining. Okay, so we'll write here 110 into 10 raised to 3 Newton per mm square. Okay, so here similarly the same procedure, 42 into 10 raised to 3 Newton per mm square. Okay, remaining is an mm square. Then for bulk modulus there is one formula which is E equals to 3K in bracket 1 minus 2 mu. But E is known, K is unknown, and we'll need to find out the K here. Mu is also unknown. Okay, so for mu means Poisson's ratio, first we find out this mu. So E has another formula, E is equals to 2G 1 plus mu. Here G is known, mu is unknown, and E is known. Okay, E is 110 into 10 raised to 3 equals to 2 into 42 into 10 raised to 3 in bracket 1 plus mu is here. So mu value is 0.31. 0.31 is nothing but a mu here. Okay, so we'll put that mu into this formula. So E is 110 into 10 raised to 3 equals to 3 into K is unknown in bracket 1 minus 0.31. Okay, so by calculating this we get K as 96 giga Newton per meter square. Okay, you can calculate these answers. So here we get the bulk modulus as 96 giga Newton per meter square. So option B is correct. Formulas are E is equals to 3K in bracket 1 minus 2 mu and E is equals to 2G 1 plus mu. These are the two formulas. Trick is here converting the meter into mm and converting the giga. 1 giga is equals to, or you can take for giga is 10 raised to 9. Okay, so by using this we convert this E and G into Newton per mm square. So this is how the question and answer is 96 giga Newton per mm square. Option number second is correct. Then fourth question is, how much in percentage, how much fracture strain is commonly adopted as a border between brittle and ductile material. So border between brittle and ductile material. So if the material is said to be ductile, then the percentage of elongation is more than 5%. Percentage of elongation here is more than 5%. More than 5%. And then in case of brittle, percentage of elongation is less than 5%. Okay, so it is in between 5. Okay, so here the how much percentage of fracture strain is commonly adopted in border. Okay, so here for border the percentage is 5. So option number first is correct. 5% of fracture strain is commonly adopted as border between brittle and ductile. So basic terms, ductile is nothing but if we convert the steel material into wires, okay, into wires, then it has a ductile property, and brittleness is a lack of ductility. Lack of ductility is nothing but a brittleness or a brittle material like glass, and ductile materials are mild steel, aluminium, then copper and lead. These are the ductile materials. Ductile, DW, you can remember like that, DW, ductile wires. Okay, if we need to convert the material into wires, then tensile force is required. Tensile force is required. So in case of ductile material, they bear a tensile nature of force. Okay, and in case of malleability, okay, so you can remember this malleability as MS, malleability into sheet, and ductile as wire. Okay, sheet means malleability as a property which can resist a compressive force. Okay, if you apply any kind of compressive force on a malleable materials, then it convert into sheet. Okay, and if you apply a tensile force on a ductile material, it will convert into wires. Okay, so option number first is correct for this question. Then next question, fifth question is, total number of elastic constant and independent elastic constant for material are. So elastic constant and independent elastic constant, for that there are three categories. So here we make a column for that. So in that first we take elastic constant, and in the second we take a independent elastic constant. Okay, so first for isotropic, then second for orthotropic, then next for anisotropic. So isotropic, inelastic or independent elastic constants are 2, 9 and 21. 2, 9 and 21. In case of elastic constants, dependent elastic constants are 4, 12 and infinite. Okay, this is the important table. Okay, here they ask total number of elastic constant and independent elastic constant for material. 5, 3, 4, 3, 4, 4 and 4, 2. Here this 4, 2 is matching here. So for the elastic constant for dependent and independent materials are 4 and 2. So here option number D is correct. So option number D is correct here. And if here they give an option like 12 and 9, infinite and 21. So you can choose as first, second and third. Each and every option has the answer in these three. But here they only mention a 4 and 2. So for the fifth question, option number D is correct. But this table is very important, so remember this. They ask this question in mini exam, so mark it as an important question. Then we move to next question, question number 6. Then question number 6, a fixed beam is loaded as in figure. The fixed end moment at support A is. Okay, so here they ask a fixed end moment. Okay, so in the previous video, I'll given that chart which is related to fixed end moment for fixed beams, and from that fixed end moments, most of the questions are asked because these values are constant values, and they directly ask what is the value for this kind of a beam, if it is related to, or if it is subjected to point load, subjected to UDL, subjected to UVL, subjected to eccentric point loading, subjected to half span of UDL or half span of UVL. So these kind of fixed end moment questions they ask, and this is the important question. In the previous exam within 1 year, they ask minimum two questions from the fixed end moment. So that's why this is the important chart. It has only 8 to 9 formulas, and all the formulas are important. So here this formula for the UVL, so UL formula, they ask for support A. Okay, but we'll see for support A and support B. For support B, the formula for fixed end moment is WL square by 30. Okay, but minus is here. Minus is here. In case of support A, WL square by 20. Okay, so option B is correct. WL square by 20. Then next question, question number 7. Then question number 7. In the continuous beam shown in the following figure, support moment M at 3 in kilonewton meter is. In kilonewton meter is. Okay, support third. Here they want to calculate, or they ask to calculate the support movement at this third point. So third point here, roller support is there. For second also roller support. For first, fixed support. Before solving any kind of a beam numerical, first we know about the support and what kind of reaction and movements are acted on that kind of support. So in case of fixed support is prevented or restricted in a horizontal movement, horizontal direction movement, also prevented in vertical direction movement. Okay, restricted in this movement, and it also restricted in case of a movement due to the rotational force acted on the any kind of a beam on the fixed support. Okay, so it is restricted in these three. So this fixed force or fixed beam support is with the three reactions, and in case of a hinge support is restricted and prevented in a vertical direction movement, in a horizontal direction movement. So here two reactions are there, and it does not restricted in a movement, so it does not get restricted here. So movement value is here we need to calculate the movement acted on this hinge support, and in case of here movement is 0. Okay, movement on hinge support is 0. In case of roller, we represent a roller support like this. So in case of a roller, the only vertical direction movement is restricted or prevented. Here horizontal and movement both are not present, and movement for roller support also equal to 0. So option number last, option E is correct here. For the support third, the support movement is 0 because roller support is given here. So the movement is 0. But if they ask for a fixed support, there is a one value which restrict the movement. Okay, here one value which restrict the movement, and that movement value we need to calculate here. But in case of a roller and hinge support, there is a no value of a movement, because here in case of a roller and hinge support, movement happens. Okay, movement happens. That's why no restriction movement value. No restriction movement value in case of hinge and roller support. That's why the movement value is 0 in case of roller and hinge. But in case of fixed support, for any kind of a movement, there is a restriction movement present in a fixed support. So that's why there is one value of movement in the fixed support. Okay, so option A is correct here. Then we'll see the next question, question number 8. Then question number 8, the elastic curve of a beam means. Okay, in case of a beam, bending moment term is there, shear force diagram term is there, and stress strain curve is there. Stress strain curve is a term which is related to tensile test. Tensile test on any kind of a steel or any kind of a RCC beam. Okay, so that's why we calculate the tensile test on steel and we'll get the stress and strain curve. Shear force diagram is obtained by calculating the shear force on each point and joining that point on a beam. Same bending moment is obtained like that, calculating the bending moment on each and every point and joining that bending moment point on the beam. But in case of elastic curve of a beam, that elastic curve of a beam means deflection curve. So option C is correct here. And yeah, these are the 8 questions from the strength of material. I'll upload the remaining 12 question in the next video within 2 to 3 days, because this video gets so much of lengthy. So that's why I'll upload the remaining 12 questions in the next video, and we'll see that next video within 2 to 3 days. Okay, so thank you for watching this video and we'll upload that video soon.